Welcome back to the Ministry of AI podcast. Today, we're diving into a fascinating and crucial aspect of artificial intelligence: checker bug detection and repair in deep learning libraries. Our discussion is anchored around an insightful research paper titled Checker Bug Detection and Repair in Deep Learning Libraries by Nima, Shiri, Harzevili, and team. If deep learning is the engine driving modern AI systems, then deep learning libraries like TensorFlow and PyTorch are the fuel. But what happens when these libraries have hidden defects, known as checker bugs? That's what we'll explore today. So what's the problem here? Well, checker bugs aren't your run-of-the-mill glitches. They're bugs embedded in the validation and error-checking code of deep learning libraries. These nasty little bugs can lead to silent failures, incorrect results, or even unpredictable behavior in AI models. The rapid evolution of these libraries, combined with their complexity, means checker bugs haven't been getting the attention they deserve. The researchers behind this study took it upon themselves to tackle this problem head-on. They conducted a comprehensive analysis of checker bugs in two widely used deep learning libraries, TensorFlow and PyTorch. By scouring through thousands of code commits and utilizing a method called snowball-based keyword matching, they collected over 500 instances of checker bugs. The goal? To understand their characteristics, symptoms, and typical fixing patterns. So, how can one effectively address this issue? The researchers introduced TensorGuard, a novel AI tool leveraging large language models to locate and repair checker bugs. This tool uses a smart technique called Retrieval Augmented Generation, or RAG for short. They trained TensorGuard on a vast dataset of code changes from these libraries, making it proficient in identifying and fixing bugs. The findings? Impressive. TensorGuard showed a high recall rate in detecting bugs using a chain-of-thought prompting strategy, while generating correct patches at a competitive rate compared to existing tools. Beyond TensorFlow and PyTorch, TensorGuard even ventured into new territories, identifying previously unknown bugs in Google's JAX library. As illuminating as these findings are, every research has its blind spots. TensorGuard, for instance, needs more data diversity to improve its patch accuracy across different libraries. Plus, certain types of bugs still require human insight to fully untangle. Looking forward, expanding the dataset to include libraries like Caffe or Theano could offer broader insights and enhancements. So what's the takeaway? This research marks a significant leap towards making AI systems more reliable by effectively pinpointing and rectifying hidden errors in deep learning frameworks. This means safer, more dependable AI applications, from everyday apps to crucial health technologies. And that wraps up our exploration today. The impact of this research underscores the importance of continuous improvement and scrutiny of the tools that build our AI systems. It's about ensuring that as AI defines the future, it's built on a stable, secure foundation. Thanks for listening. If you found this valuable, please like and subscribe to our channel. To advance your AI knowledge further, check out our free courses at the Ministry of AI. You'll find the link in the description below. Until next time.